This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program and guys we are going through with the advanced Hive. Let me share this particular presentation with you all. Okay, so from the Hive perspective we have gone through with the basic concepts and over there we have covered Hive basics and which was involving transactional system and the analytic systems. That is the difference we have covered over there. Then the complex data type we have seen, built-in functions, lateral views, subqueries, concept of normalization and denormalization, Hive views, and different types of Hive tables, and data ingestion onto into those particular tables. This is what we have seen with respect to the basic Hive. Moving further, then we have moved towards the advanced Hive, and what I have mentioned, if we are talking about the advanced Hive, then there are three main things that we can do. Okay, first one, like once we are creating the table, we can do the optimization on top of the tables while creating the tables. That is the first thing that we can do. Second is once we are trying to fetch the data from those particular tables. And third one is that is nothing but a certain simplification of the query structure. And with respect to the simplifications, we are going to make the life of developers easy. Okay, so that is not providing certain gain with respect to the latency, but it will provide the benefits to the developers, and he or she will be able to simplify the query structure. And over there we will be going to discuss about certain syntactic sugars. That is nothing but a predefined structure that you need to put over there in order to perform a particular task. So the agenda with respect to all those three modules containing these sub modules, first one is different types of optimization that we have discussed, partition and bucketing. That is what we can apply while creating the tables. Then joins, like if we are having two tables and we need to do the optimization while joining those particular tables, then join optimization is there. That is nothing but once we are querying on top of the tables. So join optimization will play the role over there. Once we are trying to fetch the data from the tables. Then window ranking, sorting, CBO, and change Hive execution engine and vectorization. These are nothing but syntactic sugars. Okay, these are the optimization techniques what we are having inside the Hive. Okay, and provide you certain gain and make your life easy. So these are nothing but say certain optimization, other optimization technique. Today we will be having focus onto the partitioning and bucketing. So we have gone from the theory perspective, and from the theory perspective what we have seen over there, that is like once we are going to partition, once we are trying to optimize based upon like while creation the tables, then there are two kinds of optimization. One is partition and one is the bucketization. So once we like both of these two techniques are working on to the principle, like divide the data into the smaller chunks. So both of these optimization techniques are working onto this particular principle, divide into the smaller chunks. And then we have gone through with like the types of partitions, that is nothing but the static and dynamic. And over here, like you are having the complete awareness how many partitions you are going to create, and this is the performant one. Just try to focus onto the cursor where I'm hovering. Okay, so static partition is nothing but it is going to do optimization, more optimization with respect to the latency and all. and over here the system is having full understanding, and we are guiding the system like these are the partitions and you need to divide the data into these partitions. So prior information is there, and because of that particular reason it is the performant one. Dynamic partition, that is the second partition, second type of partition. Over here, like we the system is not having the prior information about the data set, and system itself going to decide like how many partitions it needs to create. Then very important concept with respect to the partition, it is applied once we are having the once we are having the low cardinality. So partitioning is applied onto the low cardinality columns, and bucketization is applied onto the high cardinality columns. Partition is going to do a folder, and bucketization is going to give you a file. So over here, what we are able to see is certain differences between the partition and bucketization. So inside the partitions, like once we are dealing with the dynamic partition, that is the preferred approach inside the industry. So we are preferring dynamic partitions, and once we are having dynamic partition, friends, then we are not having the prior information about how many partitions are there, how many partitions will be there. But bucket with respect to the buckets, we will be having the information about buckets like this. These many buckets are there in this particular data. Partition low cardinality, buckets high cardinality. Then each partition is a folder, each bucket is a file. Partition have unequal number of records, and bucket will be having almost equal number of records. So this is with respect to the theory part. So what is happening once we are dividing the data? Just have a look onto these particular diagrams. Then you will be having a good understanding. So say we are having a particular file, that is the huge file, and what we are trying to do, we are trying to store this particular huge file, or huge file into different machines. We know like inside the Hadoop environment or inside the big data world, the data is distributed among different machines. So this is the file, and this is the cluster what we are having, and we are trying to dump the data into this particular cluster. So this particular file, you are able to see, these are nothing. The colors are denoting like say the partition. What you can say. So if we are going to like put this particular data into these particular machines, like it is not properly grouped. So say if I need to fetch the red part, okay, so I need to scan the data from all of the machines. So from here I need to scan, and from here as well I need to scan, from here I need to scan. So I need to scan almost all the records from the data. If like it is not partition, if it is not over here, like we are having the records, and that these are nothings you can say, like say red color is denoting Delhi, and say green color is denoting Haryana, yellow color is denoting say Uttar Pradesh. Okay, so what we are having the population data, and this particular population data is distributed among the different machines, and each machine is having like the data with respect to all the records whatever is available, like whatever we are having with respect to the block, each and every machine is having with respect to that. But like if we are able to scatter, if we are going to like group this particular data in this particular way, that is nothing but we are creating the partitions. Over here, like the entire data is scanned from this particular node. If we need to fetch the red the population from the Delhi, that is nothing but the red color. If I need to fetch the red color, that I need to scan all the records from this particular machine, this particular machine, this particular machine, and this particular machine. But if I have done the partition or bucketization, and if I place this particular the record in this particular way, so as and when required, if I need to get the red one, then only these particular records will be scanned. Rest of records will not be touched. So this is the principle in bucketization and partitioning. We are going to divide the data into the smaller chunks with respect to its cardinality, and then or with respect to the column based upon what we are going to query a lot. So based upon that, we are going to do the partitioning and bucketization. And one point what I that I have mentioned in previous session, you need to do the partitioning or bucketization based upon the column where you need to perform the query multiple time. It is not like, say, you have done the partitioning or bucketization based upon the column which is not uh, required. So that will not provide you any gain. So those particular things you need to keep in your mind. So this is nothing but the principle how the bucketization or partitioning is working. So let's proceed further for the day 19, and that will be the practical on to the partitioning. Okay, that is session 2 and advanced Hive. So, with respect to the advanced Hive, what I have mentioned, we can apply the optimization while creating the table. That is nothing but the first kind of optimization. Optimization while creation of the table. Okay, and that is nothing but partition and bucketization, partition and bucket. And if we are talking about partition, that is of further two types, static and dynamic. Static and dynamic. So dynamic. So we will be going through with the partition, and we will try to see what is the static one and what is the dynamic one. Partitions. So in order to get the understanding about the partition, there are certain steps what we are going to perform. Okay, so first we will go through with the static partition, and then we will move with the dynamic partition. No? Static partition. So in order to perform the static partitioning, what we need to do, we are having three main steps. First, creation of the partition table, then loading the data, and third one, scanning the data. These are the three steps that we are going to take in order to get the understanding about static partition. And we know static partition is nothing, but we need to decide like these are the partitions, and based upon this, we will be going to do the optimization. Second is uh, these are the performant one, and the main thing is that uh, the partitioning is applied once we are having low cardinality. Okay, so we are trying to get the understanding about the static partition, and in order to apply the static partition, let me walk you through with the data set. And for this, what we are going uh, to do, we are having certain data set, Hive data set. Okay, so order city. Let me check. Open. CA city. Okay. CA with state. Okay. So what we are going to do, we are going to take these particular orders file, order CA and order CT. So what we are having, these are the, this is certain, these files are the certain orders data from, say, this is CA is from the California, and CT you can say another, that is the another state from US. Yeah, and this is nothing but say order ID O1, O2, O3, C1, C2, C3, that is nothing but the customer ID. P1, P2, P3, that is nothing but the product ID. This one is nothing but quantity. And what I can do, this is nothing but the amount, and this is the zip code of this particular orders uh, underscore ca.csv. So these are the orders file. These are nothing but certain files from the CA state, California, what I can say. And this is a city. You can take city is city extension of USA. Let me check. City. Uh, city. Connecticut. That is nothing but city. Okay. So this is the second state what we are having. So we are having the orders data from these two states, and what we need to do, we need to do the partitioning. We need to create the tables, and we will go through to get the understanding about the partitions. So over here, what will be the schema for this particular data? Uh, huh. Let me first open it. So what we are going to do, we are going to create a table. So creation of the partition table, that is the step number one. Create say orders without partition. Order static. Order static table. Create table order static. That is nothing but the static partition we are going to learn. And this particular table is having id is of string type. Then what we are having, customer id. Yeah. So order id, customer id, product id. Yeah. Let me mention order id. Yeah. Order id, customer id, that is of string type again. Product id, string type. Okay. Then what we are having, we are having quantity. Guys, please go on mute if you are not speaking. Quantity, and it is of integer type. And amount, I think amount and zip code. Amount, and it is of say double type. And zip code. Zip code, and zip code is of say character. Let me take character. Character say 5 or 6, whatever. Okay. So this is the table, partition with, partition by, partition by what? Partition by state, and that is of say character 2, row format delimited, and fields. This is the CSV file. So fields terminated by, fields terminated by friends,
Comma.
comma. Perfect. Huh? Okay. So so we are going to create the order static table that is having these particular columns, and it is partitioned by state, and state is nothing but this particular information says CA, CT. Yeah? So this is nothing but the state information. It is partitioned by state, row format delimited, fields terminated by, not field, fields terminated by, comma. Perfect. Let me copy this and paste it inside the Hive terminal. What is partition by spelling mistake? Partition by. Okay. Show tables, and what we are able to see, order static table has been created. And if we are going to check the records from this particular table, this is the blank table and nothing is there. Okay, order static dot order ID, product customer ID, product ID. This is nothing. No records has been loaded in this particular table. That is fine. So that is perfectly fine. Now what we need to do, we need to move with the second step, loading the data into partition table.
Okay. Before
Partition
proceeding the
table.
further, hello.
Guys, please go on mute. Please go on mute if you are not speaking. If you are not having any query, please go on
No,
mute.
no, having the query.
Yes, yes. Please speak loudly then.
Okay. So my question is here, like while creating the table, for
Mhm.
the data type, you are using the double amount double. First time I saw this one. I think we can go with the int na or float.
No, 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 no. Just have a look. Double. Why I have used double? Because over here we are having records in this particular 1.11, 2.22, 3.33, right?
Okay. And what about the zip code? Care you are
Zip
using?
code you can use as integer, but like I have used as a character. I just try to give you a feel of different data
Mm-hmm.
type, right?
Okay, fine.
Perfect. So we have created the table that is nothing but the partition table. Now it's the time to load the data, to dump the data into this particular table. And what where we are having the data, we are having the data over here. So these are the files what we are trying to dump inside the orders table. Let me copy the path. Uh-huh. So this is the path where the raw data is available, and order cs is under ca underscore dot csv. This is the first one, and ca underscore ct. Ct is the smaller one. So these are the files what we try to dump into this particular table, and that is nothing but the partition table. So this file is available onto onto the local of this particular machine. So load data local in path from this particular location into table. Which table? Order static, and we need to provide the information, that is partition information, partition and state equal to CA. Okay, state equal to CA. This is what we need to do once we are going to create the static partition table. Over here we are having the information that this particular file is having the records with respect to this particular state. Okay, this particular file is having the records with respect to the CA state only. Okay, and what I have mentioned with respect to the static partitions, you are having the prior information that these are the partition that you are going to create. So over here you are going to create the partition manually. Manual intervention is required in order to create the partition, but once you are going to create the dynamic partitions, you just need to mention the column name that based upon this particular column I want to have the partition. There is no need to explicitly mentioning the partition, like I want to have this partition. That is not required in dynamic partition, but in static partition, friends, you need to have the information about, like, these are the records with respect to this particular state and all. These are the records with respect to this particular partitions. So just copy and paste it over here. So the records are dumped into this particular path, and in the same fashion what we are going to do, we are going to load the data for the city state. So into the table order static, and instead of this we are going to mention say city. City, and let me copy this one and paste it inside this particular Hive terminal. Perfectly fine. Now select star from orders. Order static. Okay, and just have a look. We are having the information, we are having the entire data, so we are having the records. What is there? Let me try to minimize this. Okay, so over here like we are having order static, the quantity is not coming properly, probably like a certain data type issue. Okay, so order state C and CT. Yeah, so these particular this particular information is there. Over here like order state, that is what like we have mentioned over here. So once you are going to do the partitioning, once you are going to perform the partitioning, the partition column will be outside from the normal table definition or table schema creation. So this is nothing but the data type and all with respect to the columns what we want to have. But if you want to do the bucktization and all, so bucktization column can be available inside this particular just focus onto the cursor, this blue part. So party bucktization will be inside this, but once we are going to perform the partitioning, it will be mentioned outside this particular definition. So partition by state, so this is mentioned over here, and we will be having the information with respect to the state. Now the main thing what you need to do, the scanning. Scanning with respect to like select star from this particular order static, we are able to get the records. But the main thing what you need to check, you need to check it with the, what you need to check, you need to check it inside the HDFS, how it will be available, how it is going to minimize the scanning. So over here, just have a look. So we will be having the order static table, and inside the order static, previously, if we are going to create a table, then with the table name we are having the part file, but over here we are having the folder name, state equal to ca. So this particular folder is containing the records with respect to the ca only, and this particular folder is containing the records with respect to the. Now if you are scanning the records from this particular table, and if you mention say just the provide me the information with respect to O10, O10, that is order 10. And once like I'm going to get the information about the order 10, and I'm mentioning say state equal to say city. So it is not going to scan all the records, only this much of records will be scanned. And how it is going to pick, it is going to pick from this particular folder structure. Okay, over here we are having the records with respect to the ca, and that is nothing but a partition. Okay, and if we need to check this partition, these partitions, so we are having a particular command, show partitions, orders, and static, order static. So this particular table is having state equal to ca and state equal to ct. These are the two partitions in this particular table, and who has created these particular partitions? We have created, and this is the beauty of this static partitioning. We as a developer needs to define the partitions like based upon these particular uh, records, or based upon this is the partition name, or this is the column based upon like I want to do the partitioning and all. So we are having complete or total control onto the static partitioning, like it is requiring the human intervention. We need to create the partitions. We are having the prior information that these are the partitions in this particular table. Okay, so we can check the partitions, and we can scan or reduce the amount of scanned data based upon the static partitioning. And this is how like it will be visible inside the HDFS. So we will be having this particular path. Let me copy this and paste it over here. So user Hive warehouse and the batch 32, that is nothing but database. Order static, this is the table what we have created, and state equal to say CA, and state equal to city. So this is nothing but state equal to ct. Okay, this is nothing, these are nothing but the folders with respect to ca and ct state. In these particular folders we will be having the partition file. Just have a look. Okay, just have a look over here. If I'm going to click and just have a look over here, this is nothing but the partition file. Okay, or the block file basically. So we are having say order csv in this particular uh, partition folder. Okay, and if we are going to mention say describe formatted order static. Okay, so manage table num partition 2, that's what I want to show you. Okay, so this is nothing but the manage table, and it is having two partition and certain other information. This is nothing but the schema for this particular table. Partition information, we are having what the column name is state, and its data type is like the character 2 what we have mentioned, and like we are having two partitions, num partition 2. Okay, so two partitions are there in this particular table. So this is nothing but the static partition. Just have a look and ask if you are having any doubt. Mm-hmm.
So can you just repeat
Mm-hmm.
the scanning the data third part? Okay.
Okay, so scanning is nothing but we are trying to fetch the records from the created table. Okay, so select star from order static, that is nothing but we are trying to fetch all the records. This is going to scan all the record from this particular table. But how the partitioning is going to provide you the gain? So if you are going to scan the data from this particular folder, or if you want the records of CA state only, then this much of records will be scanned. This much of records will be scanned. CT will not be touched. CT will not be touched. So this is the beauty of this partitioning. It is going to reduce the amount of scanning by implementing the folder structure what you are having. So if the query is like you need to get the data with respect to state and all, so over here, like say if we are having 30 states inside the US, so there is no need to scan all 30 states. If we want to have, if you want to get the data with respect to one single state, then there is no need to scan the all the 30 states. So say if I want to scan the CA state, so I just need to mention like where the state equal to CA, and this much of record will be scanned. It is not going to scan the entire data. And how it is possible? Because it has created the folder structure inside the HDFS. Okay, over here we are able to see it with the GUI inside the the name node. We are having the file system. Inside the file system, the metadata is maintained. Oh, sorry, the actual data is maintained at user Hive warehouse, and the metadata is maintained inside the MySQL. So with respect to the actual data, we are having different partitions, and by mentioning that particular partition, the scanning will be reduced. How we will be able to see the partition? So we are having say show partition command, show partition, and we just need to mention the table name orders static. Okay, so to get number of partitions, partitions. So scanning is nothing but fetching the record, that is the simple one. Okay, and the main thing is what we can say inside the scanning, like how it has reduced the amount of scanning. So by implementing this particular folder structure, we are able to see the amount of scanning is reduced, And if a table is having say billions of records, and it is having say 1,000 partitions or 2,000 partitions, and if we are mentioning a single partition, so it is going to scan that particular partition only. It is not going to scan the entire data. And because of this particular reason, it is going to boost the performance of your query. If you are going to find, like with the selects command, if you are going to find certain orders id or product id, then the statement will keep on running, and you will not be able to get the outcome if the data is used and no partition related stuff is applied over there. So try to do the partitioning, and it is going to add the optimization. It is going to boost the performance, and that's what we are able to see over here. If we are going to scan, say, let me try to show over here. Okay, so over here we are not able to see the major difference because the data set is very small. Like if we are running select star, so it is able to provide you the outcome in 0.167 second. And if we are going to get the records with respect to the city state, so it is providing me the outcome in 0.212 second. But in the actual environment, once we are having the huge data set and we are trying to get the data with respect to a single partition, this is like the logical one as well. Like if we are going to scan thousands of records, then it is going to take more time. If we are scanning say 10 of records, it is going to take less time, so we will be able to see the actual performance once the data set is used. But with respect to provide you the understanding, this is perfectly fine. And over here, what we are able to see are the static partitions. Inside the static partition, we as a developer needs to define the partitions where we are trying to dump the data. So we have defined two partitions over here, and with respect to these partitions, we are dumping the data, right? And we have created the partition based upon that particular data, right?
One thing,
So
Ashok,
scan.
I
Hmm,
have a query. Sorry.
hmm.
Uh, this is when we have already bifurcated files, right? We have different files for CA, we have different file for
No, no,
city.
no, no,
Then
this is not like that, so
uh,
if
once we
you
have a
are
complete
having,
file, suppose we have a single file and we
if
have to
you are having single file, then also
hmm,
you will be able to create the partition on top of that particular data, right? I will show you that particular stuff as well. No need to worry.
fine,
You will be able to
fine,
create.
right.
Okay. Any doubt? Anything else? Mhm. Okay. So this is what, with respect, like what we have seen with respect to the static partitions. Now, dynamic partitions. Dynamic partition. So what is the dynamic partition table? What is dynamic partition?
No manual intervention required. It's automatically fetch the how many partition in there in a column.
Speak loudly.
No manual
Speak loudly.
intervention required. Just put the column name and it's automatically fetch how many partition required. This column.
Perfectly fine. Huh? So this is dynamic partition table. Huh? Okay. So system is going to take care about partition, and there is no manual intervention. This is less performant if we compare it with static partition table. Partition table. And applied on what? Low cardinality column. Okay, perfectly fine. So in order to have the dynamic partitions, we need to set certain properties in Hive. So inside the presentation, I'm having those particular properties. Okay, so these are the properties. Let me copy. So before moving with dynamic partition, we need to set certain properties. We need to set certain properties. Set hive dot execute dot dynamic partition equal to true, and dynamic partition mode equal to non-strict. So these are the two properties that you need to set in order to get the benefit of dynamic partition. And how you will be able to set, just copy these properties and you just need to paste it over here. Okay, so this is set, and if you want to see the values, say mode. Okay. Mhm. So how to check instead of set? I think Mm-hmm. Just a minute. Hmm. Get. It's not working. Show. Mm-hmm. Hmm. Okay, that's what I want to see. Set Hive execute dynamic partition. So the property outcome is true. So it is set to true, and that is what we are expecting. Let me copy and paste it over here. So with the help of this particular parameter, set Hive executor dot dynamic partition true. So we have set it to true, and uh, once we are having this particular property that is set to true, then we will be able to take the benefit of of dynamic partitioning. The second one is like we need to have the more non-strict. Okay, and these are the two properties what we need to set before dynamic partitioning. Okay, so this is with respect to the property part, and this is how you will be able to see the value. Set Hive dot execute dot dynamic dot partition. Okay, and what we are able to see, its value is true. Okay, so now moving further with implementing the dynamic partition. Once we are working with dynamic partition, friend, then there are 5 to 6 steps. Let me mention uh, steps involved in dynamic partitioning partitioning what I mentioned. Okay, so with respect to steps, first we are going to create a normal table, creation of normal table, then loading the data into normal table. Okay, third one is creation of partition table. Fourth one is loading the data into partition table from normal table. Okay, then fifth one is check partitions and all, and sixth one is scanning the data and validate the SDFS part. Okay, so these are the steps. what we are going to take in order to get the understanding about the dynamic partition. So in order to move further with respect to the dynamic partitioning, what we are going to do, we are going to move with uh, the data set. We are going to move with the data set. Which data set I can have? Okay, so CA state is there, CA city with state, New York. Okay, so we are moving with these particular files. We are having like you can think in this particular way, like we are getting the data from the this is the raw data we are getting from the different sources, and what we are going to do, we are going to create a table on top of these particular incoming files, and that particular table will be the partition one as and when required. If like I need to get the data with respect to a particular column or with respect to a particular uh, uh, value, okay, so I will be able to get that particular data, and that amount of scanning must be very lesser. So just try to think over here. First we are going to create a normal table. So with respect to this particular table or CSV file, let me open this CSV file. Order ID, customer ID, then product ID. We are having quantity. Okay, one column is there, that is nothing but state. Rest each and everything is same. So what we need to do, we are going to copy this one, and I'm going to say create the normal table. Orders normal table. And what we are having, we are having another column that is nothing but say state, and state is having say character 2. Okay, I have defined this particular state over here. Let me remove this. Okay, and perfectly fine now. So we are having a particular normal table, and this is the way like how I'm going to define the normal table. This is this table I'm going to create based upon the CSV file. So this is the structure for this particular table, and it will be a normal table. Perfectly fine. So this is the data set what we are able to see. Based upon this particular data, I have defined this particular scheme, and I'm going to create the table on top of this. So let me create the table. Create table. Normal, orders normal. What is the issue? Character equal. Okay, state. My mistake, friend. Equal is not required over here. So let me paste it once again, and the orders normal table has been created. Show tables. Okay, and what we are having, orders normal is it has been created. This is the normal table. It is not having partitioning and all. If you want to see show partition orders normal. Okay, okay, so orders can't recognize the input show partitions orders normal in the detail statement. So show partitions is not a partition table. Table orders normal is not a partition table. This is the normal table what I have mentioned. This is not the partition table. Perfectly fine. So I have created a normal table. Fine so far, friends. All of you, with respect to the first point, we have created orders normal table. Right? This is not the partition table. Fine?
Fine, fine, Ashok.
Yes, Ashok, fine.
Yes, Ashok.
Yes, yes, yes.
Perfect. So the next step is what we are going to load the data into the normal table. And the step is quite simple. What we need to do, we just need to copy this particular command and paste it over here, and we just need to change the file name over here into table orders normal, and we just need to remove this one normal. Perfect. And what we are having 3 to 4 files so order static order ca with state, and then order ct with state, and ny with state ny with state let me check ct. I'm going to validate the structure of all of these files so we are having the same structure, same data set is there, so we can dump these particular files into our orders table orders normal table so it's the time to copy this particular command and paste it inside the Hive terminal one down, and let me second and third in one go, and it will be done okay, perfectly fine select star from orders normal. Okay, and just have a look so we are having the data with respect to all 3 files, and now this is the normal table and this is the big table, and what we need to do, we need to do the optimization on top of this particular table. And how we will be able to optimize this? By creating the partition so we have identified that the state column over here, the state column is what is having the low cardinality, and based upon the state column, what I need to do. So over here, friends, just try to think if you are having single file or if you are having multiple file, that is not making any difference over here. That is not making any difference, right? We are dumping the data into a particular table. Okay, if we are having a particular file that is having say orders and it is having all the state information, it will look like the table will look like say all the information will it will get from the single file only, yeah. But over here we are having three files, and based upon those 3 files we have done the ingestion 3 times, or we have inserted the records 3 times, so or we have loaded the values 3 times, so uh, that is not making any difference ultimately we are having all the records in one table, and that particular table is representing all the data, right? So we are having all the records in this single table, and this is the normal table. Over here we are not able to see like a ca is came from it is not making any sense like it is coming from one file or 3 files okay, so we are having one table. Now what we need to do, say if like the persons are scanning this particular table and they need to get the data with respect to CAs, with respect to the state and all. Now you need to do the optimization. You need to minimize the amount of scanning. So how you will be able to minimize the amount of scanning? By implementing the partitioning on top of this particular table. So in order to do the partitioning, what we need to do, we need to create a partition table and To implement the partition, it's very simple. What you need to do, you need to create a partition table. Number 3 is nothing but creation of partition table. Okay, creation of partition table. So partition table you are going to create and say orders partition. Let me orders dynamic partitioning. Orders underscore dyna underscore dynamic. Let me mention. Create table orders dynamic, and this is the structure with respect to the table. And now what we are going to do, we are going to do the partitioning based upon what? We are going to do the partitioning based upon state. Say partition by what? State. Partition by state. We just need to mention it in this particular way, and we need to remove it from this particular definition. That's what I was explaining in previous query as well. So based upon the column which is utilized in order to do the partitioning, that will come out from this particular structure, and it will be mentioned in over here. This is with respect to the partitioning only. It is not the same once we are going to do the bucketization. For partitioning, once we are going to do the partitioning, okay, the column based upon what we are going to do the partitioning, it will come out from this particular structure. It is mentioned over here. So partition by state and character is to row format delimited fields terminated by comma. Okay, perfectly fine. And it will be the dynamic table. So let me copy and paste it, and the dynamic table has been created, and it is the partition table. Okay, it is the partition table. Now what I need to do, this is the blank table at this moment. Select star from orders dynamic. Okay, so nothing is there. And if I just want to check show partitions orders dynamic. Okay, so partition information is blank because no data is there. We are not having any partition related information, so that's why it is coming as blank over here. But if this is not the partition table, then like we will be having a clause like not a partition table. We will be having error, but this is the partition table, so the error is not triggered over here. In the previous one, once we were running this particular command onto the normal table, then we were getting the error that this is not a partition table. Okay, so partition is information is blank over here. Now what we need to do, we need to dump the data into the partition table from the normal table. That is nothing but the fourth step. So fourth step is loading the data from normal table to partition table. Okay, so and it's just very simple. It will be insert into orders dynamic. I just want to insert the records into this particular table and select star from what? Select star from orders normal, and it is nothing but partition table. Partition, so I just need to mention partition and based upon what state. Partition based upon state. Okay, so insert into orders dynamic, that is partition based upon state, and what What we need to insert? Select star from orders normal. So this is nothing but the sub-query structure what we are able to see over here. What we are going to perform over here, like we are selecting all the records from orders table, and what we are going to do, we are going to dump these or insert these particular records into the orders dynamic, which is partition based upon state. Okay, so just have a look. Over here we are just mentioning the column name. We have just mentioned the column name. We are not having the information how many partitions it is going to create. That particular information is not available over here. We have just defined the column that I want to have the partitioning based upon this particular column. and and based upon this particular statement only the partitions will be created. Just have a look. Let me paste what is set Hive dynamic partition mode not strict. So we have set this particular mode. Dynamic mode at least one static partition column. To turn this off, set Hive dynamic partition mode non-strict. So we have set this. Okay, let me copy this particular statement and paste it once again. Okay, mode equal to non-strict, perfectly fine. And let me try to run this particular once again. Okay, so it is going to dump the data from normal table to the partition table. This is job tracking URL, and over here number of reducer 0, number of mapper 1, and we will be able to track this particular job from this particular URL. And once like it is executed, we will be able to see. Just have a look over here. So loading data to the table, this one, that is the dynamic partition table. Okay, orders dynamic, that is the partition table, and state equal to null. Okay, time taken, this one, loading data into CA, loading data into CT, loading data into the New York. So it has created these particular tables. And now what we are having, number of files, number of rows, total record, total size. Okay, so these are nothing but certain partitions what we are able to see on top of this particular data, and we can validate it with the help of GUI. And just have a look. So we are having orders normal, and orders normal is nothing but it is having these particular block files what we have inserted. Okay, we can have single file, we can have thousands of files, that is not making any issue. We need to have the data into the normal table. Then moving further, from the normal table, what we have done, we have loaded this particular data into the partition table. Orders dynamic, that is nothing but the partition table. So these particular partitions are created automatically by mentioning this particular clause, partition by state. We have mentioned this particular clause over here. By mentioning this particular clause, the partitions are created. So partition, we know it very well. It is going to provide you the folder, and inside the folder what we are having, we are having the part file, friends. We are having the part files. So this particular file, this particular directory is where the state equal to CA, it is having all the records with respect to the CA state. In the same fashion, if we are having CT, so it is having the records with respect to the CT. Just have a look. If we are going to download this, okay, and save this particular file, and if we are going to open this, it is going to provide you the information based with respect to the the New York. So we have downloaded, sorry, for which partition we have downloaded with respect to the city. So city, for the state city, this is the file. And just have a look. So over here, city column is not available. Over here, city column is not available. This is this we are able to get from the directory structure. This we are able to get from the directory structure. So this is the beauty of this, the partitioning mechanism or dynamic partitioning. There is no need to explicitly mention that I want to have these many partitions. It is going to check the data, and based upon the column which you are going to mention and the elements which are available in that particular column, it is going to perform the partitioning. Okay, so you might be having certain confusion that we have inserted three files, and because of that it has created three partitions. So let me try to create a table, that is partition table, based upon certain data. Let me try to check this one. Uh, hmm, hmm. Let me check over here. In Windows, I will be able to see the structure in a good way. Okay. So, customers. Let me try to open this particular customers table. Customer CSV file. No, this is not the CSV. Uh, and based upon what? Customers data. Okay, so we are having these particular columns inside the customers data. So these are the columns, my friends, which are available inside this particular customers data. Okay, so ID, first name, last name, email, password, street, city, state, and zip code. This is nothing but like certain columns which are available in my CSV file. This is the CSV one. Let me check customers CSV. Okay, this is the CSV file. So based upon this particular file, I'm going to create a table. Okay, first, and now I will be moving with those particular steps. Okay, like creation of normal table, then loading the data, then creation of partition table, loading the data, and scanning and all. Okay, so let's move further. Check the partitions. So let me try to mention these particular steps here only, and scanning. So we have done these particular things. Not an issue. Okay, and moving further with the next partition table. Okay, so first one is creation of normal table. So what we are going to do, we are going to create table and customer normal customer normal table, and this particular normal table is having ID. I need to check the data types. By default, Excel will perform the following data conversion, remove the zeros. Okay, customer. Customer, that is nothing but say customer ID. Customer ID, that is nothing but integer type. Okay, customer F name, that is nothing but say string type. Last name string type. Okay, email string type. Okay, string and string and last one zip code, that is the integer. So I'm going to create a table, and this is the let me take integer. Okay, and row format delimited, and fields terminated by comma. Okay, so I'm going to create a normal customers table, that is perfectly fine, and let me copy and paste it over here. Okay, so we are having this customers normal table. We have created a normal table. Now the second step is what? Second step is create loading the data into normal table. Second one is loading the data into normal table. Normal table. Okay, so we are going to dump the data from local. So load data local in path, and I just need to copy this particular path over here. Customer CSV, properties and share folder 1, customer CSV, into tables, customers normal, customer normal. So I'm going to load this particular data into customer table. Let me try to copy and paste it over here. Okay, now select star from customer normal limit 10. Okay, so we are trying to get certain records, and so we are able to get the record, that is perfectly fine. So we have created a table, that is nothing but the normal customer table. We have created it, and this is the normal table. This particular table is not having any partitioning and all. And if we are going to run the query, says show partitions customer normal. Okay, so that is not a partition table. A customer table is not a partition table. That is perfectly fine, and that is as per our expectation, because we have created a normal table. Now what we are going to do, we are going to create a partition table. Create a partition table. Partition table. So in order to create the partition table, the simple approach we just need to apply, and we are trying to do the partitioning based upon what? Based upon say state. Okay, so state, and we just need to add say partition by what? Partition by customer state. Okay, partition by customer state. Perfectly fine up this particular, and it will come out from this particular definition that we were expecting, and it will be say customers dynamic partition dynamic table. So customer dynamic table, it will be these particular columns, and it will be partitioned by based upon the customer state. It will be of say string type, row format delimited, and fields terminated by comma and all. So this is nothing but say the 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 partition table. Let me try to copy and paste it. So partition table has been created. Now now we are not having, this is the partition table, but this is not having any partition information. So just have a look over here. So partition customer dynamic, so it is showing the blank information, no partition is available. Now what we need to do, we need to dump the data from normal table to the partition table. The fourth step is loading the data or dump the data, insert the data from normal table to partition table. Okay, so normal table to partition table we are going to dump. So for that, what we are having, the simple command, and insert into say orders customer dynamic. Okay, customer dynamic and customer normal, we just need to change the, and it is based upon, it is partition based upon what, customer state. So we just need to mention the partition column and customer normal. Customer normal, things are looking fine. Let me copy and paste it over here. Okay, it will take some time, and now going to create the partitions based upon the data what we are having. Okay, so mapper 1 reducer 0, that is going to dump the data from normal table to the partition table. It will take couple of seconds, and then we will be able to see the data into the partition table. And over here, my friends, we have not mentioned like say this much of partitions I need to have. It is going to check this particular customer state column. It is going to check this particular column, and based upon the elements which are available in this particular column, it is going to create the partitions dynamically. Okay, so the query is being executed. It will take some time, and then we will be able to see the partitions into this particular table, and that is nothing but the dynamic partitions. Okay, we have not mentioned the partitions name over here, and that is the case. So what is the issue? Some error is there. Error is there. Okay, so runtime error. Hmm. Let me check the data. There's no any issue. Too many dynamic partitions, huh? Okay. Okay. So a lot of over here, like this is something that you need to understand, huh? Okay, so over here the fatal error occurred when the node tried to create too many dynamic partition. The maximum number of dynamic partition is controlled by this particular uh, parameter. Okay, so and this particular parameter per node, and maximum set to 100. Okay, so like based upon our data, based upon our like data what we are having lots of partition, and because of that, like it has thrown the error. Okay, it has thrown the error. So what we can do, let me try to do it in this particular way. Instead of string, say drop table customer normal, drop table customer dynamic. Okay, and what I can do, I can try to change it character to I'm moving hypothetically, and like once I'm able to run, then I will update you. Okay, so I'm going to create the tables again. Perfect. Load the data, then creation of normal table, sorry, a dynamic table, and inserting the records. Hmm. So so the error, like it can be controlled by increasing the number of partition. That is the first thing. Second one, like I can change the data type, probably like because of the string data type, it was like creating certain partitions, and it is going to move towards the higher side. As we were able to see, 47 are the total records, but because of the data type, it is trying to create more data, more partitions. Might be that can be the reason. Okay, if like we are not able to get the outcome based upon changing this particular data type, then we will try to set the property, we will try to increase the number of partition, and then it will be resolved. Okay, so it is going to create partitions, and inside the production environment, the default number, partition number, we are going to set 10,000. So still it is going to throw the error, and the error is what fatal error occurred when the tried to create too many dynamic partitions, the maximum number controlled by. So let me try to set the partitions with the help of these particular properties. Copy and set Hive, Hive execute max dynamic partition equal to say 100, set, and set Hive execute dynamic partition dot per node equal to say 100. So let me try to first get these particular values, and then we will try to increase it. Huh? Hmm. 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 First, we'll try to get these particular values. So this is okay. It is 1000. 1000 and still 1000. Just a minute. Okay, for this, like, just have a look onto these particular properties and give me a second. I will come back. Okay, so these are the numbers which are set in this particular machine. Let me try to increase these particular numbers. So say 10,000. Let me increase it to 10,000 and 1,000. 10,000 and okay, per node 1,000 and 10,000. And let me try to do the execution once again. Taking too much time, and what we can see, customers dynamic. Customers dynamic staging. Hmm. Staging Hive. And moving data to this particular location. Okay, customer state equal to null. It is taking time because we are having too many partitions. So it will be creating partitions over here. Just have a look. So partitions are customer state. I think we have taken the things incorrectly. Oh, so customer state. Why it is picking customer state? Customer state, that is perfectly fine. But why we are getting these particular things? Why we are getting these? But this is like it is because of some issue with the data set, or like we have captured the wrong file. Huh. We need to validate. We need to validate. This is customer CSV. It is available inside the share folder and comma separated. And over here, what we are able to see in customer CSV open VI. Customer zip code. I think because of the data set, there is certain issue with this particular data set, and it is picking these particular thing as the customer state. So it is not creating the partition based upon the CA, PR, CO, PA. It is creating the partition based upon this particular numerical values that we have mentioned as a string. Okay, just have a look. So time taken to write. So this much of partitions has been created based upon the customer state, and that's why like it was throwing error. Because of this particular reason, it was throwing error, right? So although like these particular partitions are created dynamically, okay, we have not mentioned anything, and this is with respect to, let me try to download this and get the outcome of what is available in this particular file. Email not available. Customer ID, that is fine. This first name, last name, email, password. Email password. Let me try to copy it and paste it over here. That validation is mandatory and that is required. And what we are able to see, we are able to see the records in this particular way. And just have a look what is happening. Let me try to mention with respect to the one record only. Hmm. So this is the data set what we are able to see in the CSV file. This is inside the CSV file. And this is what we are able to download. Over here up to here, that is fine. We are able to get the records properly. But this particular column, that is the state information, this information, it is taking it in this particular way. Okay, so because of the data set related or data type related challenges, okay, it has thrown this particular error, and it has created how many partitions. It has created almost, show partitions, customers, dynamic. Okay, so almost like 1001 rows. So 1000 partitions are there in this particular data set. 1000 partitions. So big, as we are having max partition limit that is set to 1000. Previously it was 1000 and we have increased it to 10,000. Because of that it was throwing error. So friends, like what we need to do, we need to check the data type and all, and we will be able to get the actual outcome. The main intention is you to give you the insight like how the dynamic partitioning is working. And you can take it as an assignment like why we are not able to get the partitions based upon the state. We are getting the partition based upon the next column. Okay, so try to do it with respect to the things, customer city, zip code, partition state. Things are looking fine. Okay, so what you can do, it might be possible that is because of some column structure. Try to copy this particular data. I will share this particular sheet. Try to copy this particular data into the different sheet and try to pick 10 records or 20 records, create table on top of those particular 10 or 20 records, and then try to insert and create the partitions and all. Right? So try to do that. Probably you will be able to do that. The main intention was to give you the insight like how the dynamic partition is working. And we have seen these particular parameters only in order to increase the number of dynamic partitions. It was set to 1000 previously and it was set to 100. This is default. These were the default values. Let me copy and paste it. So these are nothing but the default values. Default. Okay, now you might be worried, like why the Hive.
Ashok, this partitions per node means?
Huh. Okay, so partition per node it means, just have a look over here. What we are doing over here, this is the cluster. In this particular cluster we can have 10,000 partitions. Yeah, but in one machine, right? Just focus onto the cursor. We can have, earlier it was set to 100 and we have increased it to 1000. So in one node I can have 100 partition with respect to a particular data. Perfect, fine.
Yes, yes, got it.
Okay, so friends, what you need to do, you can take it as an assignment. Try to create the partition, dynamic partition. Let me mention over here. Try to create the dynamic partition based upon the data customer CSV dot CSV CSV and validate it. Okay, okay, so you can take it as an assignment. Okay, and I was trying to explain something. So friends, in actual production environment, we used to set the 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 default the max number of partition, that is 10,000. However, like with these particular parameters, you are able to increase or decrease the number of partitions, right? But you need to tell me why there is the limitation that I need to have maximum this much of partitions. Okay, what is the limitation? Like if I can set the number of partition to say infinity, what will be the issue? Or say if I'm having 1000 1 lakh record, so can I have 1 lakh partitions? Hmm. Tell me,
No, no, no.
why we are having these particular parameters?
Because
Or in another words, what is the benefit of these particular parameters? Okay, let me try to explain. So friends, what is happening? Hive is smart enough in order to provide you the optimization on top of your data. Okay, and partitioning is what we are having inside the Hive, which is going to do the optimization. That is a technique. So it might be possible by mistakenly we have fired a query or command, and that is going to create hell number of partitions inside the Hive. Okay, and that is not going
Sorry,
to.
Ashok, can you please repeat it because there was a disconnection in between. So
Okay,
not able.
so okay, so why we are having these controlling parameters in order to control the number of partitions? Because Hive is smart enough in order to provide you the insight. You can think in this particular way, like by mistakenly you have fired a command, and where the cardinality is very high. That happened in our
Hope your voice is not coming.
Ashok, you are not audible.
to set the you are trying to create the partitions beyond the limitation, beyond the limit. So this is the limit which Hive is set, okay, with respect to the one node cluster. So you are trying to create the partitions beyond the limit, and it has thrown error. Then we were able to get, like, it is because of uh, like the issue that we are trying to create more partition. We have validated the data, but what we got, like, the data is data, there is no issue with data, but it was picking this particular column because of certain and all. I don't know, like, what is the issue with this particular sheet. It's going to pick this one, and based upon that, like, we are able to get so it is going to pick these particular you can say columns and all, and It is going to create the partition. But with the help of these particular parameters, we are able to get the information that we are trying to create more partitions beyond the limit. If we are having certain checks or certain triggers, once we are going to fire a particular command and we are able to get that we are going to create beyond the limit, then that will be a benefit. So in order to give you certain benefit that you are going to get the actual optimization, like partition is designed in order to provide you the benefit, like the scanning will be less. But if you are going to create too many partitions, hell number of partitions, then you will not be able to get the gain. So this particular parameter is is utilized in order to control the number of partitions per node and in total, so that you will be able to get the real optimization, right? Fine so far?
Yes, yes, Ashok.
Yes, Ashok.
Okay. Anything that you want to ask? Let me ask by name. Gaurav, Vikas, Rohit, Pankaj, Mukesh. Okay, anything
No,
that you want to get,
No, fine
that
fine
so
you
far.
want
so
to
far.
ask?
Also fine right now.
Okay, so that's it. This is with respect to partitioning. Try to implement it by yourself, and try to do certain exercise, and it will give you a lot of confidence. Okay, so that's it for today's session. I will share these notepad
Ashok,
and
one question.
files. Mhm.
Hello, Ashok.
Please ask.
Uh, uh, while doing the partition, the only way is to transfer data from one table to another table. We can't load directly data CSV file or text file into the partition table.
Come again.
The step is that we load in partition is that we load data in normal
Uh-huh.
table and then we transfer this data into the partition table. Is it
Hmm.
possible to load directly to the partition table through CSV?
No,
No.
no.
Okay. Okay. This is the only way.
Yeah.
Okay. Thank you.
Okay.
Okay. Okay. Sure. Thank you.
So that's it. Anything else? Anything that you want to discuss? Okay. If nothing is there, we can conclude the session for the day. I will share these files with you all and try to do the practice. Thank you.
Thank you, Ashok.